Here we see the sponsor scene with motion blur using 32 motion samples. For comparison, we show a rendering without motion blur. The plots show the rendering times of our technique compared to the time-sampled tracing technique for both 4 and 32 motion samples. Using only 4 motion samples results in a larger amount of noise. Our version only slightly increases rendering times when switching from 4 to 32 motion samples. In comparison, time-sample tracing is significantly slower with 32 samples. Here we show the generation of the disocclusion map. The result of an edge detection using a Laplacian filter is shown in blue. The yellow color marks areas that contain disocclusions. We then combine the information of both buffers to create the disocclusion map. The disocclusion map is then used to modify the original depth buffer. This visualization shows the number of collected opaque T fragments. Here the collected transparent T fragments are shown. This is a visualization of both opaque and transparent T fragments. The chalet scene features a large amount of transparent fragments, especially at the edges of leaves. Again, we show the number of collected T fragments as well as the rendering times using 4 and 32 motion samples respectively, compared to the time-sampled tracing technique. The San Miguel scene uses depth of field in addition to the motion blur shown previously. Our approach uses 4 depth of field samples with 8 motion samples each, resulting in 32 samples per pixel, while the time-sample tracing approach uses 32 samples per pixel. Due to the lower number of traced depth of field samples, our approach shows more noise in still frames. On the other hand, in areas with larger motion, our technique allows us to draw large numbers of motion samples at low cost. This is again a visualization of the number of collected T fragments. Thank you for your attention.